In this tutorial I'm going to show you a simple method how to cover up texture tiling. I've already made one tutorial with different method that used multiple textures. However, this one has a couple of disadvantages in that it's view dependent and it doesn't really play nicely with virtual textures. So here's a different method that doesn't have this problem. This one works by splitting the surface into a number of areas and applying the texture with different offset and different rotation onto each one. Okay, so let's start. So here's our very basic material, and for now I'll just unplug everything, and we are going to start by making those different areas. And for that we can use vector noise, and we're gonna need coordinates for this noise. However, the problem is the texture coordinates are just 2 parameters, and we're gonna need 3. So let's break out float 2 and make float 3. We're gonna leave the z coordinate blank, so like this and like this. And let's visualize what it looks like by plugging it into texture, and let's see. And here we have those different parts. We can make it better by using Voronoi rather than solenoise, like this. And now we're gonna use custom rotator. There we go. And we're gonna plug the UVs in here. We're gonna break this into 3 components. First 2 will go into rotation center, and the third one will be rotation angle. So let's make another float 2 here. So this goes here, and this goes here. So now it outputs the texture coordinates, but rotated around a random rotation center. Sorry, I made a mistake here. So around the original coordinates rotated around random rotation center by a random amount. And now when we plug it all here, here we go. No more tiling. Well, it's not quite perfect yet. There's 2 issues with this. The first one is that you can see, when you look closely, lines where the different sectors join up. So we're gonna have to do something to break up those straight lines, make them maybe a bit curvy, so they're less obvious. Okay, let's clean it up a little bit, because we are going to add a few more nodes. And we're gonna use another vector noise node, and this time we're gonna use parallel 3D noise. And we're gonna plug in the same coordinates. Okay, let's visualize what it looks like. As you can see, these are a bit noisier, but we're gonna have to use those to sort of offset the coordinates that are used for the second vector noise. So I'm gonna add here. and the result of first vector noise goes to coordinates of the second vector noise, and the resulting shader looks like this. And now you can see there are no more straight lines, but the separation is still easily visible, so we could make it maybe a bit noisier by multiplying those coordinates. This should make the noise smaller. Let's multiply it, let's say, by 10. In your use, you're gonna have to like find optimal value for each texture at which it hides those separations the best. And we're gonna add another multiplier in here, so it's not too noisy. Let's say 0.1. Okay, this looks exactly how it should. And let's see what the resulting material looks like. And as you can see, or rather not see, those divisions between texture repeats are no longer really visible. The second problem isn't actually really visible on these particular textures, but there are some on which it is. Okay, let's find some. Okay, here's one. So you can see here the lighting on this normal map is rather inconsistent, like different rocks appear to be lit from different side. And to fix that, you can go to the normal map texture sample, and here you can add derive a tangent basis. You plug the normal into normal and the texture coordinates into UV, and instead of the normal map you will use the world space normal output. And as you can see, now the lighting is consistent despite the normal map being randomly rotated.